Okay.
A lot of students come to the class without running through
So, get our practice test out.
They need to go get one.
Everybody got lanyards on, everybody in uniform, let's take our coats off. Here we go. We are on practice test 2. We have a test. We have a test on Monday. Those of you who feel ready to take the test after school on Thursday can do that if you'd rather get it over with. So we're on practice test 2. We're ready for problem number 5, right? So here we go. You're going to choose 3 cards. This is important. 3 cards. So whatever you do, make sure you got 3 cards. We want 1, or probability, 1 diamond and 2 clubs. What's the denominator going to be? It's a probability problem. 52C3. Why is it 52C3? 52 cards, picking 3, right? Now, what's the numerator? I want 1 diamond and 2 clubs.
So 1C1.
How many diamonds in the deck?
So there's 13.
13. So we're going to pick one of them. There's 1 diamond, right? And 2 clubs. 13C2. That's exactly right, Sam. 13C2. There are 13 diamonds. We want to pick 1. There are 13 clubs. We want to pick 2. So we can type that in on our calculator. And did you get 0.0459? You got fractions? Yeah. Okay, that's fine. Let me see if mine makes it a fraction. Yeah, 39 over 850. Yeah. That would be fine also.
Oh.
You can answer as a fraction or as a decimal. We've said that lots of times. Okay? Exactly 1 king. Now, this is where sometimes we make mistakes. How many cards are we drawing?
1.
No. 3. So if we have 1 king, then don't we need 2 other cards?
Yeah.
Don't forget about those other cards. What are those other cards? Anything except kings, right? All right, how many kings are there in the deck? 4, and you're getting 1. How many other cards are there in the deck? 48? Because there's 52 altogether, but 4 of them are kings. So there's 48 cards that aren't kings. And then still 52C3. Is that okay with everybody?
Yeah.
Now stop and think, just be organized. 4 kings, 48 others. I want 1 out of the king pile, 2 out of the others. All right, and that is gosh, I got 0.2042.
Yep.
Is that right? That seems kind of high. That's 1128 over 5525 if you do it in fraction form, which again, it doesn't matter. write C. More than one diamond. Now, just stop, think. What does that mean? More than one diamond.
2 or 3.
You could have 2 diamonds, or you could have 3 diamonds, right? Now, 2 diamonds or 3 diamonds. Now, how many cards are we taking in this hand? 3?
3.
So if 2 of them are diamonds, what does that mean? You gotta have 1 other card? Now, if 3 of them are diamonds, I don't need any other cards. But if 2 of them are diamonds, I need a 3rd card. How many diamonds in the deck? 13. C2. How many non-diamonds in the deck? 39. C1. So there are my 2 diamonds and 1 other card. What do I do with the or? Plus 3 diamonds. What would that look like? 13C3. And then again, this is probability, so the whole thing's over 52C3. I got 0.1506 or 64 over 425. Anybody match that? Okay. All right, what do we have next? The frequency table. Find the mean value. Okay, so this is number 6. Frequency table, find the mean value. Okay, who remembers how this works?
3 6s.
Uh-huh, that's exactly right. I don't know who's talking back there, but you are exactly right. This means there are 3 6s. So I have a list of numbers. I have 3 6s, 10 7s, 4 10s, and so on. I want to find the mean. How do we find the mean? Add them all up and divide by how many you have. So what am I adding up? I'm adding up 3 6s, right? 10 7s, 4 10s, and so on. So what do we get when we add all those up? Let me see just a second. I believe you. Oh, what'd you say?
41.
241?
Yeah.
Yeah. So we get 241 when we add them all up. Now, how many are there? Well, be careful. There's 3 6s and 10 7s. So if we add, isn't this row the one that tells us how many we have?
Yeah.
Those are the frequencies. So 13, 17, 18, 19, 24. So our mean is 10.04. Is everybody okay with that? That was on a quiz and some of you didn't do so well with it. Do you get it now? Is everybody clear? All right, so now we got teachers eating M&Ms. Here are how many M&Ms the teachers ate. Find the mean, median, and mode number of M&Ms. So what do we need to do? Put them in order. All right, so let's see. I've got a 0. And then I've got a 2 and a 5. And 8. 1 1, 2, 3 10s. A 12, a 15, a 16. A 20, 24, 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think I got them all. All right, mean, median, mode, which one do you know? The mode, we can tell right now, the mode is 10, because we have more of those. Mode most, okay? Now the median's gonna be the one right in the middle, right? So you can either do this, you know, and just kind of keep zooming in on the center, or since there's 13 of them, the 7th one will be in the middle. So 1, 2, 3, 4, 5, 6, 7. So the median is also 10. And then how do we find the mean? Add them up. Yep. So. I got 160. I'm not sure, did I get everything? Okay, and there's 13 of them, so that's 12.31 for the mean. Everybody okay with that problem? All good? All right, the probability that Sam eats a candy bar with a soda is 94. Probability he eats a candy bar without the soda, he has a soda 92 times. What's the probability he won't eat a candy bar? All right, what's your strategy?
Tree.
Tree diagram. And whenever we do a tree diagram, we gotta decide what we're gonna start with. What's gonna be this first branch?
Soda.
It's gonna be soda. And the reason it's gonna be soda is because the question is candy bar, so that has to be second. So soda. So he's gonna have soda or no soda. All right. What are my probabilities for soda and no soda? 90 and 10. So then he has a candy bar or no candy bar. So candy bar is 94. Be careful on this one. What will be the no candy bar probability here? 0.06. Don't put 0.6. It's 0.06. And 76. And 24. What is the probability he won't eat a candy bar? He won't eat a candy bar. So we need these, right? In agreement? All right, let's all calculate it. Let's all do it together. Do you know what you're supposed to be typing?
Yes.
Okay. I got a final answer of 0.078. See if that's what you got. You got that too? Okay, Marcella, you participating, honey? You wanna take your coat off and wake up? You need to go see the nurse? Okay.
When we write probability on the test, we need to have a unit.
No, probability does not have a unit.
Okay, so just write it as a decimal.
Just a decimal or a fraction or a percentage. Yep. Now, if it says how many students ate lunch in cafeteria, then you would put, 232 students. But probability has no unit.
Can you make a problem about me?
I will do that. But it'll take me a while. I'll do that. But
What is that? It's 0.06 times 14.
no. it's 0.9 times 0.06, and then it's 0.10 times 0.24. Each branch gets multiplied, yeah. All right, here we go, number 9. Consider the set of numbers 1 to 25. Choose a number. What's the probability that it is less than 3?
Same.
What's the probability it's less than 3?
2 out of 25.
2 out of 25. Why is it 2 out of 25? Because there's 2 numbers in that list that are less than 3, and there's 25 altogether. A multiple of 3. Well, what are the multiples of 3 in this list?
3, 9,
3, 6,
9, 12,
9, 12, 15, 18, 21, 24.
15.
A multiple of 3, you know what that is. 1 times 3, 2 times 3, 3 times 3, something multiplied by 3. So, how many are there?
1, 2, 3,
8.
8.
So the answer is 8/25. Alrighty. A faculty was surveyed as to whether they like subbing or not. The data is summarized. So somebody's done some surveying here. And we like to sub and we don't like to sub. We got male and female. So there we go. Information given. Find the probability that a randomly selected teacher will be a male who likes subbing. So here's your pot of teachers. You're going to reach in and grab one. What's the probability you'll get a male who likes subbing? 6 out of 39? How did we get 30? I think that reduces, but before we do, how did we get 39? All these people added up. Probability is out of the total, right? And there are 39 total people. So that does reduce, so we always want to reduce our fractions. So 3, is that 2/15? So that would be the probability of getting a male who likes subbing. Okay? Now, I want to take my survey results and I want to kind of extrapolate them onto a bigger population. So suppose I had 300 teachers. How many could I expect to not like subbing? Well, how many of my teachers didn't like subbing? 23 out of 39. So that proportion of teachers does not like to sub, according to my study. So what would I do to figure out how many in a population of 300? Just multiply. Just multiply, that's exactly right. So you just take the probability of what you want, which in this case is not subbing, and multiply that times the number of people you have in your population. So 23 divided by 39 times 300. I got about 177 teachers. Is that what you got?
Yeah.
That would not like to sub. Last problem on this practice test. We got 40 music fans at a concert. Look at me, I'm already drawing my Venn diagram. When you read this, do you feel like Venn diagram? You got people who like jazz and people who like country and people who don't like either. Want to know how many enjoy both. So we've got our jazz and our country. We got 28 in the jazz circle. We got 30 in the country circle. And we got one of them out here who doesn't like either one. That's important. Why is that important? Because it means the circles only hold 39. Right? So somehow all these people gotta be in 39 spots. Which means some of them are more than one spot, right? Okay, so what do I do? Add these two together, that's 58. Huh? No. So now I gotta subtract 39 because there's 58 people here, but I only have room for 39. So how many extras do I have? 19. So there's 19 people that overlap between the two groups. Which means if this is 28, there must be 9 here. And there must be 11 over here.
Plus.
Do these add up to 40? All these 4 numbers here, do they all add up to 40? They sure do. So now we can answer the question, how many enjoy both kinds of music? 19 fans. 19 fans enjoy both kinds of music. All right, so we've been through the test twice now. We're getting ready to start our 3rd time. You need to start keeping notes about what we need to practice more, because not tomorrow, but Thursday, I'll see you again, and we'll have some time to practice whatever we need to practice. All right. Huh?
Are you gonna hold play?
Uh-huh. Let's start practice test C. Ready? I see Tylen's already coloring, because what are we doing in the first part of the practice test? Shading, right? So you're figuring out what you need to shade. And if all the letters confuse you, think of it as raspberries and strawberries or something like that. Lemons and mangoes. All right, where'd you shade here? In that first one with the R's and the S's, where did you shade? Everything but the circles? That's exactly right. We're gonna shade everything but the circles. Why? Because this means everything in the circles. That means you like raspberries or strawberries. That's all these people like raspberries or strawberries. This means you don't like raspberries and strawberries, right? Which means you're on the outside. All right, where did you shade here? Did you get to this one? Where did you shade?
L.
Not the whole L though, just this part of the L.
Just L. Because people got like 11.
L alone, just lemons. The people who like just lemons. Because this says you like lemons and not mangoes. So that's just lemons. Everybody okay with that? Right side up U means everything. Upside down U means and. Means just the overlap. Okay. All right. Okay, what about the next one? How did you start this one?
Put the both.
We know this is point 2, right? Because what does that upside down U mean? And A and B football overlap. Now that automatically means then that this section is
What?
0.6
What?
and this section is 0.1. What do those add up to? 0.9, which isn't enough in a probability problem, so there must be an additional 0.1 out there. So apples and bananas. Here's the problem. What does it say? You don't like apples and you don't like bananas. Well, if you don't like apples and you don't like bananas, where are you? You're outside. So the answer is the outside part, which is 0.1. This says you like apples or bananas. Well, if you like apples or bananas, you're in the circle somewhere. So if you're in the circle somewhere, that is
Inside.
0.9. Okay, there's no partial credit on those problems. Does that make sense to everybody? All right, let's have you pick some M&Ms out of 2 different bags and see what you come up with as answers. So do it on your own. I'm gonna turn back a few papers. See if you can figure these 2 out. We have 2 yellow, and we have 1 red and 1 blue. See if you can figure those out. While I clean up attendance here.
Like, I don't want to say it out loud because that'd be weird. Alright. Alright, here we go. What did you come up with for the probability of getting 2 yellows? Are you on practice test C? Yeah.
Okay, yellow out of the first bag is 0.1, and yellow out of the second bag would be 0.1, so the answer should be 0.01.
Oh, I thought it was 0.2.
Everybody got it?
And we multiply.
Yellow and yellow? Now, what about red and
If
blue?
the 2 equations could denote the order.
Exactly. So we're going to do red and blue, and then we're going to do blue and red, right? So here we go. Let's get red first. So red first would be 0.2 times 0.2. So 0.04. Red out of the first, blue out of the second. Or, let's see, blue out of the first is 0.2. And red out of the second is 0.3.
Mhm.
So that's 0.06. Now what do I do with those two numbers? Add them. So the answer would be 0.10. Kyla?
I thought we had to do the yellows 2 times.
Why?
Because it could be yellow or yellow or different other way, yellow and yellow.
Okay, but wait. Yellow out of the first, yellow out of the second is exactly the same as yellow out of the first, yellow out of the second. There's no difference there.
Okay.
They're exactly the same situation. Right?
Yeah.
Yeah, so no, if they're the same, then it doesn't matter where you get it the first or second. Okay. Consider the set of numbers 1 to 35. Alright, so this time you're looking at the set of numbers 1 to 35. What's the probability I'll reach in and grab one that is more than 30? 5 out of 35. How many numbers are more than 30? 31, 32, 33, 34, and 35, right? So 5 out of 35, which reduces to 17. A multiple of 17.
17, 30,
The only multiples of 17 in that list are 17 and 34. Multiples of 17 are 1 times 17, 2 times 17, 3 times 17, and so on. There's only 2 of them in our particular list, so that would be 2/35 would be the answer. All right, now we have kids eating Skittles. We want to find the mean, median, and mode number of Skittles. All right, so what do we need to do? Well, half of you are busily writing, which is a great thing. What are you doing? What are you writing? In order? So it looks like I have a 2 and a 6 and 1, 2, 3, 4, 5 8s and 3 10s. 13, 2 15s, and 1 16. Is that it? Oh, and 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them this time. Yep. Alrighty. What is the mode? Looks like 8. Is 8 the mode? What about the median? Let's see, we said there were 15 of them. So 1, 2, 3, 4, 5, 6, 7, 8. I think it's 10. And then for mean, we'll just add them up. If I added anywhere near right, I got 155. Anybody else get that? Okay. Everybody all clear with this kind of problem, mean, median, mode? Good? Everybody's gonna get that one right? Good. Alright, now we have dogs in the pound. 15 of them have pit bull, 16 have lab, 22 have collie, 6 dogs have all 3. What am I gonna do with this? Venn diagram. And this one is gonna be a Venn diagram with 3, because we got the pit bull, we have the lab, and we have the collie. And there's 40 of them all together. And we know the pit bulls are 15, the labs are 16, and the collies are 22. Six dogs have all 3. 3 are pure pit bulls. 1 is a pure lab, and 5 are pure collies. All right, Emmett, you know what to do now? Yeah, that didn't sound very convincing.
Here's only a lab column mix, so we're gonna make a Venn diagram.
Yep.
Yeah. You'll need to set up your equations.
Yep, I got some empty spaces that I don't know what they are. So I gotta figure out what those are. So what will my equations look like? Here are the totals right here. What will my equations look like?
3 plus 6 plus X plus Y.
X plus Y plus 3 plus 6 equals 15.
Yep.
And X and Z and 6 and 1 is 16. And Y and Z and 6 and 5 is 22. Do those equations look okay to everyone?
Mm-hmm.
All right, so X plus Y equals what? Let's move this over. So I think that would be what? X plus Y equals Jackson, what's X plus Y equal? 6, yep. And what does X plus Z equal, Jackson? And Y plus Z. Perfect. Now let's add these together. So that's going to give me Y minus Z equals -3. Not a problem, that's fine. And Y plus Z equals 11. So what do I do now, Marcella? Yep, the Z's are going to cancel. So 2Y equals 8. So Y equals 4. And then I can just fill in the rest. So let's see. This must be 2. And what was this 7? How many dogs are in the circles? 28 in there? Which means, oh, there's only 28 in there? That means there's 12 out here? You alright, Toby?
No, I'm not okay. I need to go home. I'm so sick.
Oh jeez, we're all done. Oh, we're all done.
Alright.
Oh,
What's the
no.
probability that he's only, what's the probability that you reach in and grab a dog And he's a lab collie mix.
7.
Lab collie mixes are right here. So 7 out of 40. What's the probability you reach in and grab one and he's not any of the 3? 12 out of 40, which you're going to reduce to. Is that 3 over 10?
Yeah.
Everybody got it?
Yeah.
Okay, here we go. Let's get as much of this done as we can so that next time we can do whatever you need to do.
Wait a minute.
Oh, what time does it end?
40.
Oh, does it end at 40? Okay, all right, you're right. I kept thinking you had to go later. All right, so we'll just stop right there. And then we will finish this next time. But keep in mind, if you have particular problems, mark those so we can talk about them next time.